This video is going to be an example of using ANSYS to do the same kind of fluid flow simulation that we did in the previous week using SolidWorks. So let's get started. Now, first of all, I want to show you what not to do. The obvious temptation of someone just starting out in simulations is to say, I want to do a full three-dimensional simulation. It's a computer. It should be able to do all of this stuff. So what I've uploaded in this model, and I'm going to show you quickly and then go back to actually doing it properly, is I uploaded a wing model in SolidWorks. Now I'll open it in SpaceClaim. And you'll see why later, because we'll have to do that with a two-dimensional model as well. And here's SpaceClaim, and this is showing you what I've done is I've just simply taken two solids. One was a wing and one was a block, and I subtracted one from the other, and I came up with this volume, which is the volume of fluid that I'm going to simulate. So for ANSYS, you need to create the volume of fluid. And once you've done that, then you can work on the simulation. So I'll just close that. Now, I've already loaded it into Fluent. I've loaded the geometry. I've specified, in this case, 3D here. And this is important because we're not going to do that later. And if I then go to the mesh, I've already got that open, so I'll just pop it open here. And what I simulated was that block, and you can see that I started out with a simple simulation of a reasonable amount of grid elements, and you can see that in order to create a reasonable size mesh, I need to get down to the size of, in this case, a millimeter or half a millimeter of grid point sizes around the wing. And you saw in the SolidWorks simulations that if we didn't get to a reasonably small size of grid points at the wing, then the simulation didn't make any sense. And so I've started off with that presumption here in ANSYS. Now, if I look at a section plane, and you can see with the section plane what this really means in terms of the grid points. So if I just drag my section plane, you can start to see how really fine some of these points are. And just turning off the section plane and back to the bulk. If I look at the mesh and I look at the mesh statistics, I have in this model, that number at the bottom there is 26 million grid points. 26 million grid points. Not likely to solve that on your laptop, even if it's a Mac. So really, it's not feasible to do a full three-dimensional external flow problem and do it realistically using, well, either ANSYS or SolidWorks. There's just too many grid points that need to be solved for. And in fact, as you'll see, the iteration number in this is 100 or more to get a good solution. And so that's just going to be unwieldy in terms of time. In fact, it took my computer 10 minutes just to create the mesh for this particular model. So we're not going to do this. So now I'm starting fresh, and I want to do a two-dimensional wing analysis, similar to what we did in SolidWorks. And I create a Fluent standalone. Geometry-wise, The first thing, and fundamentally important before you do anything else, is go down here and select two-dimensional. If you've done that, then everything else will be reasonably okay. So we'll just leave that. Now, we don't want to use space claim, so I'm going to import geometry from SolidWorks. Now, if I go into SolidWorks, this is the wing that I'd used in last week's videos, except I rolled it back a little bit. I started off with the curve, and then I created a sketch around the curve, and I rotated the wing so that it's tipped down at 10 degrees. So I have this large square, and I have the wing tipped at 10 degrees somewhere in the middle of the square. Now I could, or the rectangle. Now I could mark the rectangle to give me some dimensions. Again, go through the previous videos with SolidWorks and you'll see the implications of the size of that computational volume. And I leave that as is. I scaled it in this case to make it to make the wing the same size as I did in the previous simulations. It's a 10 centimeter long foil. And the only thing that's different here is that I took that sketch and I applied a surface plane to it. And that just made this whole section a plane rather than a solid. Now, we need to do that in order for it to be able to be imported into ANSYS as a two-dimensional body. So if I go and save as, I can save it as a step file, as we've done already. Save it as a step file, and everything will be fine. And I'm just going to save that. Now back to ANSYS. If I go into ANSYS, and there's two things I could do. One is if I right click on geometry, I could import the geometry directly from SolidWorks, which is what I'm going to do. I'm going to import that step file. Now, one of the things that you'll find is if you proceed at this point, even though it's got a check mark and the geometry has been imported, you'll find that there'll be errors when you try to translate the file into Fluent. So one of the things that we need to do to make this work smoothly is now that we've got the geometry in, edit the geometry in Space Claim. And there's Space Claim. Space Claim has opened the file. Everything looks just fine. Nothing's changed. And we don't have to do anything. We can just simply save that. And it's going to save it as a Space Claim doc. And that's exactly what we want. If you don't do that, as I said, and you just have it in there as the direct file out of SolidWorks as a step file, it'll cause problems. Fluent doesn't recognize the geometry as a plane, unfortunately. So we'll close Space Claim, and then we can open the mesh. So right click on there and edit. There, we've imported the geometry, and everything looks like it's good to go. It looks just like the file in SolidWorks. Before we do a mesh, one of the things that we need to do is, if you just highlight the mesh, it's going to make it a lot easier to start naming surfaces or naming edges. So I'm going to select the Edge Select tool here, and I'm going to select that, and I'm going to use Control to hold that down, and Control, hold that down, and I'm going to right click now, and I'll create a named section. I'm going to call this Inlet. Now the reason I've selected the top wall and the bottom wall and the front face as the inlet is that if I don't do that, then I have to come up with some other boundary condition for the top and the bottom. This way my boundary condition will simply be the same as at the front, which is there'll be a horizontal airspeed flowing into there. And if I do the same for the rear of this, create a named section, and I'll call that outlet. And then the last thing I want to do is I want to select the shape there. You'll also notice that the foil is imported everything except that little piece at the end here, and it is also another surface, another line. So if I select both of them and I call them both my named selection, and I'm going to call that the wing. There. If you don't select the small piece there, you'll just have to have two surfaces every time you want to choose anything. So just to check that out, we can see what is our named section, and it's everything right to the end, so that's correct. We can check and see what's our outlet, and it's that at the edge, and our inlet are all those surfaces. So that's good. So now we've got the geometry defined, and we'll be able to define the boundary conditions quite readily. So the first thing we want to do is the mesh now, and the mesh, we can choose a variety of parameters here, and we can just leave that as the default for the mesh. And the first thing I want to do is a sizing tool, and I'm going to select for this that whole body. Whoops, that body, and I'll apply that. And the type of size that I want to do is not an element size. I actually want to create a sphere of influence. So what I'm going to do is I'm going to make the grid sizes around the wing different than everywhere else. And I'm going to pick a vertex. I'm going to select that. Oops. Apply that. So I've got that as the center of my sphere of influence. And because my my foil is 10 centimeters in length, I'm going to pick 12 centimeters as my sphere of influence. So that should give a range just around the foil of finer grids. And for my element size, I'm going to pick 0.5 millimeters. So half a millimeter. And we'll see what that does. So now if we generate the mesh like this, it's taking a really long time for this meshing to happen. And don't be surprised if it takes a really long time. Well, that was a bit of a pain, waiting and waiting and waiting for my mesh to be created. And let's see what I got out of that. So this is the mesh that waiting for that created. I can actually just click that and get the two-dimensional. Yeah, that's not quite what I had hoped. I made it so that the size was a millimeter, and it's fairly even, which is great, but there's a lot more grid points than I had hoped in areas that I'm not that interested. It would probably simulate okay. If I look at the mesh statistics, you can see that I've got 47,000 elements there. That's a lot better than 26 million, but it's still a lot. So I could try one of a number of different procedures. The first thing I'm going to do is, even though it took a really long time for it to solve that, I'm going to modify my vertex sizing. So that's a good lesson. When you're selecting in 2 dimensions, if you select the body, it will try and calculate grid points for sections of space in this sphere that are not actually on the surface, and it'll take a really long time. If you select as a surface, then it goes quite quickly. Now, in terms of my mesh size, let me just generate. There, I increased the size, so now I have only 3,200 points, and that doesn't look like a lot, and it's not, but I'm not done yet. The next thing I want to add to this is I want to add an inflation. So what this will do is I can pick, first of all, in the scope, that surface and apply it. And I'm going to select a boundary, but because I've already got named sections, I can just choose the boundary, which is the wing. And it's chosen the boundary of the wing. And what I want to do here is I want to make a total thickness. Essentially, I want to make grid points around the boundary layer. I'm going to pick 10 layers, and the maximum thickness of my boundary layer, I'm going to make that to be, I could calculate the boundary layer thickness would be the ideal in a hand calculation, but I'm just going to, for the sake of illustration, make that 2 millimeters. And so now you can see I have a similar grid points to what I've had before, but what I've got in close is this array of boundary layer elements. And these elements are important in simulating the wing. Now, because I've made them so coarse, I've captured what is a fairly rough surface in here, and I want to fix that. And I'm going to fix that in one way, which is I'm going to take that sphere of influence sizing that I'd chosen an element size of 0.05, and I'm going to make that 0.015. And there we have a much nicer mesh. You can see we've got the sphere of influence is quite large, and if we look here, we have the boundary layers, and the grid points look fairly decent. Okay, well, we'll stop there for a moment. We've created a grid, and it looks like it's sort of reasonable. Now, the sphere of influence that I showed is fairly starkly different from the circle around the wing to the rest of the grid. It would be nice to soften that, and there's some more tweaks you can do to the settings to make that right, but for the moment we'll proceed.